All right, in this video, we are going to be talking about how to interpret a derivative. And you're going to need three things. You are going to need time, the context of the problem, and the derivative with units. And obviously, if it's increasing or decreasing. Make sure that whenever we are interpreting something that you pay special attention to double negatives. If you say decreasing at a rate of -3 units per second, then essentially the rate is increasing, so we don't want that. All right. So the temperature of a coffee cup at time t is bounded by the decreasing differentiable function c, where c of t is measured in degrees Celsius. For 0 to 12, selected values of c of t are given in the table shown. And for part A, it says to approximate c prime of phi. Remember that the derivative is the same thing as slope. So if you aren't given something, if you're given a table like this, you're just trying to approximate the slope at 5 using 2 points. In this case, we're going to be using 3 and 7. So this is essentially saying 69 minus 85 over 7 minus 3. That is going to give us -4 degrees Celsius. Now remember, that was your numerator, and then your denominator is time. So you want degrees Celsius per minute. So we want a rate. So something over something. Now the second part says interpret our answer in context. So here we're just going to copy and paste this lovely thing right here into a sentence, but with this context. So this is saying at t is equal to 5, okay, now what are we interpreting? The temperature of a coffee in a cup is, okay, now is it decreasing or increasing? We know that it is decreasing because I have a negative, so is decreasing at a rate of 4 degrees Celsius per minute. I should also include minutes right here. So at t is equal to 5 minutes. There's your little sentence right here. So you need 3 things. All right, part B says, is there a time t from 0 to 12 for which c of t is equal to 80, and we want to justify our answer. Now, remember that this right here kind of looks like, IVT back in Unit 1. So here, if I were to look at 0 to 12, notice how I'm going to hit 80 somehow, some way, somewhere. I just don't know where. I don't care, but I know I'm going to hit it. But how do I explain that to the readers? Because on number 14, it doesn't tell us anywhere in the problem that the function is continuous. Oh, wait, it does. Remember that if a function is differentiable, then the function is going to be continuous for those selected intervals. So whenever you are justifying your answer, you're going to say that because c of t is a decreasing differentiable function from 0 to 12, c of t is continuous from 0 to 12. Great. So we know that's continuous. What we need to look at is 0 and 12. So I'm going to say that C of 0 is 100 and C of 12 is 55. So now we just got to go ahead and put that in inequality notation. So C of 12 is less than 80, which is less than C of 0. So because that's true, there exists a time t from 0 to 12 such that C of t is equal to 80 degrees Celsius by IVT. You don't need to include the by IVT part, but it's there for the LOLs. All right, yay. All right, 15. We have a 12,000 liter tank of water is filled to capacity. At time 0, water begins to drain out of the tank at a rate modeled by R of t measured in liters per hour, where R is the piecewise defined function below. A says determine if R is continuous at 5, and we want to show the work that leads to your answer. So here, remember that if I want to find if something's continuous, I got to look at my left-sided limit and my right-sided limit of this function. So I need to figure out if the limit as t approaches 5 from the left of this thing right here is going to be the same thing as this thing over here. All right, so what we're going to do is go ahead and pull out our handy dandy calculator. I'm going to be using my little applet right here. And I'm going to go to Y1 and Y2 to plug in these values. So I'm going to go ahead and type in 600t and then t plus 3 and Y1. And then Y2, I'm going to do the same thing. I'm going to do 100 e to the negative 0.2x. And then what I'm going to do is do second quit. And then what I'm going to do is do alpha trace or alpha y vars, do y1 5. And that's going to give me the function value at 5 for my left-sided limit, since y1 was my left-sided limit. I'm going to do the same thing for y2, where I'm going to do alpha y var y2 5, and that's going to give me the right-sided limit at 5. And that's going to be 36.787. Now, what you're going to do is make sure that you include 375 and you include 36.787. We are going to go ahead and say that this is 375 and that this is 36.787. Now, on the AP exam, you want to make sure that your decimal is 3 decimal places, not 2, not 1, 3 or more. If it helps, do 4, 5, 6, whatever you want, but you need at least 3 decimal places, truncated or not. Now, we are going to say that because they're not equal, we're going to say that the limit, we're going to say that R is not continuous at t is equal to 5 hours, since the limit of t approaching 5 of R of t does not exist, because the limit from the left does not equal the limit from the right. All right, so part B, we want to find R prime of 3 using the calculator. Using correct units, explain the meaning of this. All right, so we have our calculator here. We don't know how to take the derivative of 600t over t plus 3 right here. Okay. As of right now, we don't know yet. So what we're going to do is use our handy dandy calculator. To find the derivative button, you are going to go to math, and then you're going to go all the way down to 8. Math 8, nth derivative. Now, what we had already in y1 was this function right here, the 600t over t plus 3. So what I'm going to do is say alpha y var, go to y1, so that it's stored right there. That way, we don't have to keep on repeating, and we don't have to keep on typing 600t over t plus 3. Now we have x equals, and we're going to say x is equal to 3 because that's the value that I want, the derivative at x is equal to 3, or t is equal to 3. Hit enter, and we know that is going to be 50.000. So you could just say 50. So we can say that r prime of 3 is 50.000. Using correct units, explain the meaning of what that value is in context of the problem. So here, remember that we are going to use our little template. So at t is equal to 3 hours, then we're going to look at the context of the problem. So the context is the rate in which water drains out of a tank is increasing, decreasing, is increasing at a rate of 50 liters per hour square. Now you might be thinking, why is it per hour square? Well, notice how R of t already is measured in liters per hour. So I have liters per hour here. And then I'm dividing that by time again. So then I'm going to have liters per hour per hour. So that's how we get liters per hour square. All right, in the next video, we are going to be talking about particle motion, good old PVA, and what that means. Then we'll talk about product and quotient. Then we'll talk about chain, and then we'll end off Unit 2 with implicit.